go to school or college and take courses that deal with the Ice Age, the evolutionists or the uniformitarian scientists make it sound like, hey, the Ice Age is one of their best examples of slow processes over millions of years. They say there were, first of all, they said there were 4 ice ages. I mean, that was dogma for 60 years. But suddenly they looked at it differently, and now there's about 30 ice ages that repeat every 100,000 years. And then, but you go back past 1 million years, they repeat every 40,000 years, to the point where in the last 2.5 million years you have about 30 ice ages. This is what they say. And it may make it sound like, oh, you just need a few degrees of cooling and man, there's the Ice Age. It's not like that at all. In fact, the Ice Age is a major mystery of science, as I will tell you, and only the Bible can really explain it. Now that sounds like a strange title, but just bear with me. I will show you how it relates. It's not directly in the Bible. It's an inference, a strong inference from the Bible. But first of all, I told you a little bit about millions of years. I want to say something very quick about dating methods. They have a lot of different dating methods, but it's mostly mainly the radiometric dating methods: uranium, lead, potassium, argon, rubidium, strontium, isochrone method, these sorts of things that they tout as being so accurate. They're not that accurate at all. In fact, we're doing our own dating. In the Grand Canyon, we have the Cardenas basalt and the vast diabase, and they're dated about 1.7 billion years old by the rubidium, strontium, isochrone. Those are igneous rocks, and you date the time it cools. Well, up here in the northwest rim of the Grand Canyon, you have a lot of fresh-looking volcanoes, and the lava's come down and kind of has stuck to the walls. So the Institute of Creation Research has said, well, we're going to date those rocks by the same methods that they dated this lava at the bottom of the Grand Canyon. And what? Guess what? Lo and behold, you get dates older, that the time of cooling is 1.34 billion years old by the same method, the rubidium, strontium, isochrone method, which is considered one of the best. 1.34 billion years old when it cooled, when yet it cooled within thousands of years. It's older than the lava supposedly in the bottom. Something's wrong somewhere. We've done this over and over again. We're dating modern lava flows and getting millions of years, like Mount St. Helens, the dome in Mount St. Helens. Some lava flows in New Zealand that are within 50 years. So something's wrong somewhere. So Institute of Creation Research has this big research project where they're trying to find out why. And they're sort of leaning towards the idea that there's accelerated radiometric decay during the creation and or the flood. But you'll hear more about it. They got one heavy book out, which I don't think we have back there, but you have to know something about geochronology to read it. It's called the RATE book, Radioisotopes in the Age of the Earth. They're going to have a second book out in 2005, and a layman's version of it. I'm going to be really interested in how they can make this all a layman's version. That's going to be the biggest challenge of all, because it's really heavy stuff that they get into. But I have a personal reason why I'm skeptical of dating methods. As you know, was a weather forecaster for 30 years. And I did this many times. Today's weather forecast, 100% chance of sunshine. Does that ever happen in the Seattle area? And it dumps on you. In fact, that's why I became a weatherman. I said, I'm tired of with all these wrong, lousy weather forecasts. I love to hike in the mountains and backpack. And it rained on me when they said it wasn't. Well, guess what? I got sucked in, and I did it myself. But anyway, the point of this is, tell me again why I should trust scientists' ability to be accurate about life on Earth millions of years ago. I mean, I think some of these, when you read geology, they make it sound like when they're describing things of millions of years ago, billions of years ago, that they were right there. They could tell you about the soils, the climate, and the ecology, and the animals, and whether it's a marine environment, a terrestrial environment. I mean, it goes on. And they don't say likely or probably. They say that's what it is. But they had to forecast the weather for at least 1 year, and I don't think they would be making statements like that too often. But anyway, let's get into the topic. This is an overview of my talk. Now, ice ages are divided up into what's called pre-Cenozoic and Cenozoic. These pre-Cenozoic ice ages go back to 2.2 billion years in their scheme. I'm talking about their scheme. And I'm going to make a case that these are actually gigantic submarine landslides during the flood. Those are the pre-Cenozoic ones. And I'm going to make a case that a Cenozoic ice age did occur, and it's a major mystery of science. The climate change caused by the flood really initiated the Ice Age. There was only one rapid Ice Age, and ultimately, only the Bible can explain the Ice Age. That's what I'm going to be talking to you in the next 45 minutes. Okay, if we want to learn about past ice ages, I mean, there's no ice to observe. You know, what do we do? Well, we go to where there's glaciation right now and see what glaciers do. What kind of work do they do on the rocks? What kind of features do they produce? Well, good place for this is the Athabasca Glacier up in between Banff and Jasper, up in the beautiful Canadian Rockies. This is the glacier was here in 1890. That was the front of it, and practically all glaciers of the world have been receding, except some in Scandinavia. And I think it's a combination of a little bit of global warming and a little more power coming out from the sun. And if you want to know, get off on a tangent, if you want to know my opinion on global warming, I think it's 10% reality and 90% hype. Now, that's all I'm going to say about it. I could talk a whole hour on that. But we need research. We need good research into it. We've got to figure out, first of all, how significant is it? And number two, is it harmful? I got a postcard I'm going to get on PowerPoint that shows a committee in Montana where there's a shack out there, and it's snow about that deep. They're all standing around like this, and it's called the annual meeting of the Committee for Global Warming. The question is, we don't know if it's going to be harmful. Let's find out. It'll be harmful in some ways, but other ways it'll be beneficial. So is it the benefits going to outweigh the harm? We don't know that yet. We need more research. I'm for more research. But anyway, when the Athabasca Glacier backed up, it left telltale signs. See all these rocks mixed in with finer grained particles of sand, pebbles, silt. That's your typical features you see. It's called glacial till. And they formed shapes, geometric shapes like this. This is an end moraine where the glaciers pushed the rock out and formed a mound in front of it. It's called an end moraine. Right in here is called a lateral moraine where it pushes the rocks to the side as it moves out. See, the glacier continues to move out as it melts. And so if the melting is more than the pushing out, it'll recede throughout the years, and that's what's happening at Athabasca Glacier. And here's a picture of the lateral moraine as you walk up into the ice sheet. I don't recommend this to many people. This is loaded with crevasses. You can look down there and woo, wow. A nice hole down in the clear ice. It'll go way down there. Anyway, look at that sharp lateral moraine with the stones of various sizes in it within a finer grain matrix. Also, another feature it does is as rocks on the bottom of the glacier move along the bedrock, it scratches the bedrock, and the rocks in the glacier get scratched. So a lot of scratched rocks. See all these nice scratches on the bedrock? Here's a stone that's scratched, and it's scratched in two different directions at least, going this way and this way. It's because the rock turned while it was scraping the bedrock. Those are typical glacial features. And here's a scratched and grooved bedrock from the Sperry Glacier in Glacier National Park. It's been receding also. So those are typical glacial features. So you look around the Earth where there's no glaciers today, and you look for features like that if you want to discover past ice ages. So the evolutionists have done this, and all over the Earth, and they've categorized the past glaciers into 4 general categories. This is a big question mark right here. I'm not going to speak of that. This is in hundreds of millions of years right here. So this is 250 million years. The MZ stands for the Mesozoic. Anyway, I'm splitting these down into 2 sections. I'm going to talk about 2 sections, pre-Cenozoic ice ages and what they call Cenozoic. Now, it has another term called Pleistocene or Quaternary. They're synonyms for the ice ages that recently ended according to their time scale. So I'll divide it right in here. Now, you have 4 main ones in there right in here. These are all abbreviated. Time goes this way. This one, early Proterozoic ice age, occurs about 2.2 billion years ago in Ontario, Canada. The late Proterozoic one is a very interesting one. It actually spans a long time. It's about, they say, about 550 million years to almost 900 million years. It was about a 450 million year long ice age. And so far I'm not going to talk much. The late Paleozoic was one that is in many places in the southern hemisphere. You find them on all the continents in the southern hemisphere, these deposits. They're hard rocks, like you see a cliff and you see these rocks in this cliff. Well, what kind of rocks trigger the idea of an ancient ice age or a pre-Cenozoic ice age? Well, such features as this. This is a picture from Ontario, Canada, showing what's called the early Proterozoic ice age. It's stones like this within a finer grain matrix of sand, silt, and maybe even clay floating in there. This is lithified. This is cemented rock. And that is what they consider, only ice ages can form a pattern like that, is what they used to say. Now, I'm going to tell you that there's other mechanisms that can do that, but I'll get into that. Also, you find these scratched rocks. This is the late Paleozoic striated or scratched bedrock below what's called tillite. Now, tillite is hardened till. This is hard. This is hard material here. It's rock. But in that rock, you find stones of various sizes and compositions within a finer grain matrix. And above it, you find the scratched pavement. Very typical of Ice Age features. So they do have evidence for these ancient ice ages. This one would be dated about 300 million years ago. Okay? However, there's problems with all these pre-Cenozoic ice ages. Number one, when you find something they say that they believe is an ice age, you find a warmth indicator next to it, like dolomite or carbonates. They're usually deposited in warm water, dolomite and hot water. How can you have hot water indicators and cold indicators next to each other or above or below? Big problem. Also, practically all these deposits I'm talking about are marine. But most times we see ice ages on land, and they deposit on land. Why are these marine? Well, maybe it's because they were deposited by something different than ice ages in a marine catastrophe. Hint, hint, hint. Anyway, there's features you'd expect in a glaciation that are missing from these deposits. Also, that late Proterozoic ice age, as I said, was from 550 million to 900 million years in their dating scheme. They find the deposits of this mostly at the equator or near the equator or the paleoequator, and they're marine, meaning that the ice started on the pole and it descended to the tropics, covered the equator, and went all the way down to sea level. What does that mean? That's a totally glaciated Earth. So now they dubbed it Snowball Earth. And you know, that's the time when the origin of life is occurring. So they kind of boxed themselves in a corner. How is life going to evolve when the Earth is totally glaciated? And from a meteorological point of view, if you totally glaciate the Earth, chances are you're never going to unglaciate it because the reflection of sunlight from that white snow and ice is going to keep it cold. So they got some big problems with this Snowball Earth. Also, in the Sahara Desert, where there was the main evidence for the late Ordovician Ice Age, the grooves and striations which is the main evidence, is they're all going in the same direction, all over North Africa, about 2,000 miles wide. They're all going north. No ice age produces striations that consistent. In fact, even in a short distance, the striations on bedrock go this way or this way. They're different. This is consistent with what is called mass flow over a huge scale. And that is exactly what I believe is the cause of these so-called pre-Cenozoic ice ages. I believe they were mass flow, landslides, debris flows. There's lots of terminology, but it's like a landslide. It moves, and I believe it happened during the flood, so they moved long distances underwater. In fact, here's a landslide deposit in Montana, near Arley, Montana. You can see the till-like signature of rocks of various sizes in a finer grain matrix. Here's one on top of the Gravelly Range mountain, same signature. They used to think this was an ancient ice age, except when they found out they dated it at the Eocene era. That's an era of great warmth, so they had to axe that so-called ice age because it was a warm period. But up there in the top of the mountain at 10,000 feet, you find scratched bedrock and even these chatter marks where a stone is bouncing in the ice and makes a groove every few inches like that. They used to claim that this only forms in ice ages. But here we got a landslide deposit that did it. In fact, here's some of the debris you see right down here. Here's another picture of it, some of the grooves and striations on the bedrock, and here's a scratched rock, duplicating what many used to think was an ice age deposit, evidence of ice age. But this is a landslide deposit. To make a long story short, I did an in-depth study, took 11 years, and I published it in the book Ancient Ice Ages or Gigantic Submarine Landslides. Of course, this would be the submarine landslides are during the flood, and if you want to know more about it, you can get my book. You might notice that the cover is different. That book, when it was first printed, and I got the first edition back there, was dark, and there's a bunch of typos in it. Actually, not too bad, so I have it back there at reduced price. It's normally $21. I want to get rid of these first editions. I was very unhappy with them. The second edition's a lot better, but anyway, $15 for a cut rate on those. Now let's get back to what's called the late Cenozoic. I talked about these pre-Cenozoic ice ages, making the case that they're not ice ages at all, that they're actually gigantic submarine landslides that duplicated a number of what was thought to be ice age features in the past, but now a lot of scientists have come around to realize, hey, landslides can do this. Let's talk about the late Cenozoic, what they call the late Cenozoic or Pleistocene or Quaternary. I'm going to ask 3 questions in regard to this. First of all, do these deposits really represent ice ages? That's the first question we ask. I mean, let's find out if they're ice ages before we try to explain it with an ice age mechanism. Number 2, can an ice age occur in the present? Is an ice age easy in the present climate? I say present because the uniformitarian scientists rely on present processes to account for the past. So they got to use present climatic changes to account for the ice ages. That the remnants of the ice age right now are Greenland and the Antarctic ice sheet, but I'll show you. This area was glaciated during the ice age. There's some nice ice age features in Puget Sound area. The third thing was there more than one. They claim there were up to 30 in the late Cenozoic, 30 ice ages in regular succession. Okay, in dealing with the first question, you go to the areas where we feel, or they feel, it was glaciated and look for glacial signs. Well, you know, they're all over the place. This is west of Great Falls, Montana, where I lived for about 28 years. And here's the Rocky Mountains. The Rocky Mountains up in here were glaciated. Glaciers came out of valleys, and they formed distinctive features, like this end moraine. This is a typical end moraine. Here it continues over on this side where I took the picture, and you can see it's stones of various sizes piled up. And here it was breached, probably from when the ice melted, it breached the end moraine and flattened it out. Then I went and looked at part of the end moraine, and lo and behold, it was stones of various sizes in a finer grain matrix, typical of glacial features. This is a place that gets up in the lower 80s in the summertime, where the idea of ice ages not that long ago just seems totally unreal. And then when you go up into the canyon, the Sun River Canyon to the west of that, you find the scratched bedrock. This is a cliff 800 feet high right here, the first cliff before you get onto the high plains, and look at the scratched bedrock you find there from a past glacier that went up and over the cliff. And here's some of the rocks you find in the end moraine down there, scratched rocks of at least 2 different directions. And then closer to home here, in the Wallowa Mountains, and in a lot of other mountains of the western U.S., the mountains of the western U.S. were mostly glaciated, the Sierras, the Yellowstone. This is the Wallowa Mountains. This is a beautiful lateral and end moraine, a small end moraine and a big lateral moraine forming a horseshoe shape in the northern Wallowa Mountains near Enterprise. Enterprise is out here about 4,000 feet above sea level. It gets up there in the 90s in the summer. An over-deepened lake, typical of glaciers that go down channels or valleys. They tend to over-deepen valleys. Beautiful. That lateral moraine is 600 feet tall. Very sharp looking, indicating that the ice age was not that long ago. And yet the idea of having an ice age here just seems totally unreal. Then when you look at the material in the lateral moraine, yeah, it's a typical till signature with rocks of various sizes in a finer grain matrix. So the conclusion is that, yes, this place was glaciated not that long ago. And then you find these erratic boulders here and there. And this is one of the most famous erratics, 30 miles southwest of Calgary, Alberta, called the Okotoks erratics. Very sharp. They didn't roll. This is quartzite. That had to be drifted down on an iceberg, and it probably came from around Jasper National Park. Carried long distances just sitting out there on the plains. No quartzite outcrops on the plains. this guy for scale is John Woodmarape, who wrote that great book, the feasibility study. And then when you add it all up, this is what it adds up. It was glaciated about 4,000 years ago in the creationist time scale in these areas. Right in here. Here's the northern boundary. Some of the mountains in the west were glaciated. But guess what? Look at that. Where a place we'd expect to be glaciated, the lowlands of Alaska, were never glaciated. And that's where you find those millions of woolly mammoths. I got a book coming out on that from Master Books this fall called Frozen in Time, Woolly Mammoths, the Ice Age and the Bible. And we get into that. That's a whole different talk. I don't want to get off the subject. Anyway, in Europe, this is the corresponding ice where the ice was in Europe. Most of England, northern Germany, northern Poland, etc., into northwest Asia. The Alps were glaciated, and the central mountains of Asia were glaciated. That's where we find it was glaciated not too long ago. It includes the Puget Sound area. You go along the beach in Puget Sound, you can find a lot of scratched boulders. So the question, do these deposits really represent ice ages? I would say yes. There's no way you can account for these by landslides because it's over too flat of terrain. Central and eastern Canada are very level. There's no way you're going to get this whole area just covered with glacial till by a landslide. So there was a huge climate change that did this. Number two, can an ice age occur in the present? Well, first of all, we've got to figure out what kind of conditions do we need for an ice age? What are the requirements for an ice age? Well, the first ice requirement is obviously cooler summers. Like, I mean, if you wanted the ice to come back here, you got to cool off the summers. Now, in this place, winters are too warm still, but most areas where the ice occurred are already cold enough in winter. That's not a problem. In fact, you'd like the winter to actually be warmer because the warmer the air, the more the moisture it holds. So warmer winters would really help an ice age, but cooler summers, you especially got to have cooler summers. Number two, much greater snowfall. Much greater snowfall. And number three, it has to persist for many years. If you could find a climate change that caused a cooler summer, that may be possible, but it's got to persist year after year, and it's got to build up to form an ice age. Well, how much cooler? Well, a guy did a computer study in Canada, and he found out, well, I want to ask the question, how much cooling do I need of summer cooling? How much do I need to cool those summer temperatures in Canada off to get 1 inch of snow to remain, winter snow to remain until the fall? That was the question, just 1 inch. So he cooled it off by increments of 2 degrees. So when he cooled it off 10 degrees, this is where the 1 inch of snow persisted. 12 degrees, that's in centigrade, that's 20 degrees Fahrenheit. That's where the 1 inch persisted until the fall. Just 1 inch. Only there. 20 degrees Fahrenheit, that's for northeast Canada. But the ice was clear down south of the Great Lakes. You need much greater cooling. How much? Well, let's take a city like Minneapolis. The average temperature in the summer there is 70 degrees Fahrenheit. That includes your max and mins, and divide by 2, that's 70 degrees. Now in Antarctica, the melting doesn't just start at 32 or anywhere, especially in spring and summer, because solar radiation is the most powerful energy source for melting snow, not temperature. So it's the solar radiation which is powerful in the spring and summer at mid and high latitudes. Well, in Antarctica, they observe that net melting occurs when the temperature warms up to 14 degrees Fahrenheit. If anybody that lived in North Dakota or Montana, we have these spring storms, they'll dump snow, and the sun comes out and it rises to 10 degrees Fahrenheit and the snow starts melting at 10 degrees Fahrenheit in the spring. So net melting is at 14, but I'm going to be conservative and say Minneapolis summer temperatures had to drop to at least 20 degrees Fahrenheit for net melting. That's a change of 50 degrees Fahrenheit for the summer. Where are we going to get that in present processes over millions of years model? You're not going to get it. There's no way that they could even think of it. Therefore, the Ice Age is a major mystery of science. And here's a series of quotes in 1957 from the giant book. It's a 1,600-page book. In fact, that's a quote from page 1,532. It's called The Quaternary Era by Charlesworth. He says, the Pleistocene phenomenon, that's Ice Age phenomenon, have produced an absolute riot of theories. Yes, at the time of this writing, there are 60 theories of the Ice Age. Kind of competes with the theories on the demise of the dinosaurs. They have about 60 of those, too, that are very entertaining. But they range from the remotely possible to the mutually contradictory and the palpably inadequate. That's not saying much for those uniformitarian theories. Oh, but that was in 1957, and we know so much more now. We do? Well, here's 1996 in the popular journal Earth, which is now defunct, I believe. Daniel Pendick said, if they hadn't actually happened, the ice ages would sound like science fiction. And in a 1997 issue of U.S. News and World Report, August 1997, they reported on 18 great mysteries of science. These are their best mysteries of science. It's kind of entertaining when you go through that, because some of these mysteries are mysteries of their own making because they believe in evolution. Like what happened to the dinosaurs? Well, they died in the flood, except for those that were on the ark, and they died out in the cold climate after. But notice this one. Can you read that one there? Why do males exist? Well, why is that such a mystery? Well, because in evolution, everything should reproduce asexually. The idea of having a male and female just can't figure it out by evolution, you know. But of course, we have an easy answer. In the beginning, God made them male and female. It's just so simple from the Bible. So these are problems of their own making, but some of them aren't. One of them is what causes ice ages. It's considered the top 18 problems in science. And just recently, David Alt, in his book Glacial Lake Missoula and its humongous floods, by the way, I think there's only one humongous flood. But anyway, he says, although theories abound, no one really knows what causes ice ages. So ice ages are a major mystery. How do we explain it? Well, here's how we explain it. The flood not only produced all those vast amount of fossils and sedimentary rocks, it perturbed the climate. You probably had a warmer climate before the flood, and during the flood, you caused conditions that would have a climate change afterwards, called a transitional climate, until you got to the present, right in here. And well, what are those features that perturb the climate to cause an ice age? Well, here they are. The volcanic dust, see, the flood was a gigantic tectonic event with crust moving up and down, and also a lot of volcanism. In fact, I think they estimate 25% of sedimentary rocks are probably originated from volcanoes. Anyway, at the end of the flood, you'd have all these volcanic dust and aerosols. And aerosols is a fine-grained particle. Aerosols cause cooler summers over land. In other words, the sunlight reflects back from these and cools the land, especially the mid-latitude continents, mid and high-latitude continents. It doesn't affect the ocean, by the way, because of the heat capacity of the water. Number two, the fountains of the, I thought I corrected that. The fountains of the great deep and volcanism caused the oceans after the flood to be a lot warmer. This is a very key feature. Warmer water, the warmer the water, the more the evaporation, by a considerable amount. So we had warm water from the bottom of the ocean to the top, from the Arctic Ocean to the Antarctic. In fact, you might have been able to swim in the Arctic Ocean right after the flood. It was that warm. And that would produce so much evaporation at mid and high latitude, right next to where the ice sheets were building. That's your tremendous moisture supply, is that warm ocean. And the mechanism will persist until the volcanism decreases after the flood and the oceans cool. And here's an example of how the reflection of sunlight back to space works, like this. Now, there's one slight problem in this, is that volcanic ash and aerosols filter out of the stratosphere slowly, 1 to 3, 1 to 5 years. So you need to replenish that volcanism with time. And that was done after the flood, and the evidence we have of that is the tremendous evidence of volcanism in Ice Age sediments. And on deep sea sediments from the Ice Age period, you have lots of evidence of volcanic ash. So it was a very volcanic period that would replenish the aerosols and the ash in the stratosphere to keep the Ice Age going. Charlesworth says, signs of Pleistocene or Ice Age volcanicity and earth movements are visible in all parts of the world. Now, the evolutionists know that volcanoes cool the earth. I mean, we've observed this in the last 200 years with the big eruptions that have gone off. Not Mount St. Helens. Mount St. Helens was a little eruption, believe it or not. But Mount Tambora, Krakatoa, there was a huge eruption. Pinatuba and others. They cooled off about 1 degree Fahrenheit over the whole northern hemisphere, or a good part of the northern of the world. So we know it cools. But why can't they see this as a cause of the Ice Age? You know why? It's because of their time scale. Their time scale is stretched out so much that we're talking about several 100,000 to 1,000,000 years where they have this volcanism they observed in the Ice Age period, to the point where it's insignificant. But we telescope it within a short period of time, it becomes very significant. You know, I'm finding out in all I do that time is a key factor. Our short time scale is a key factor of solving major mysteries of science. Major mysteries, our short time scale. Time is not a side issue in the creation-evolution issue. I'm finding it very crucial for solving major challenges, major mysteries of that they can't explain. And on basic meteorology, you can, because of the general current winds going from west to east, you can figure out where the major evaporation areas are. And they're generally on the east coast of continents, and in the Arctic Ocean is where they are, and that's just exactly where the ice built, real close to that major evaporation for the ice sheet over North America. And you could figure out major storm tracks just by basic meteorology, because the storm tracks generally follow the areas where you have the strongest horizontal temperature differences. That's just basic meteorology. That's where your jet stream will be, and the jet stream guides the storms. And so you can have some general storm tracks. You're going to have one major storm track south of the ice sheet, because the ice sheet's cold and it's warmer over land, so it's going to follow like that. Then the warm ocean right out in here, and then you get the cool land and ice sheet's going to cause another storm track out in here. Then when it gets out in here, it's going to lose what it's called its thermal support, and they're going to break up and go all which directions. These are average storm tracks. Now in meteorology, chaos theory usually reigns, so you're going to have storm tracks, a lot of different ones, but these are average storm tracks. Now this storm track here is the northeaster storm track that really blasts the East Coast every winter with snow that deep. And I would say you probably would have northeasters with the temperature staying constant like this for years and years. You'd have maybe a northeaster every 2 weeks, and they'd be huge northeasters that dump huge amounts of snow. So you can have a rapid snowfall. So the ice age would occur rapidly. How rapidly? Well, here's my evidence for that it was a rapid ice age right here. This is it, Jenkins. Indisputable proof that the ice age caught these people completely off guard. There's my evidence. Now let's get serious. The ice age will quit when the controlling mechanisms slow down or end. And the main one I found was a cooling of the oceans. Once the oceans cool, they don't evaporate enough moisture to keep feeding the ice sheets, because they do have some melting in summer. And so melting in summer becomes more powerful to the point where they build up to a maximum and then they melt. So it was actually a very simple calculation. I mean, in theory it was. The variables were speculative. I'll get into that. It's simply the heat balance equation of the ocean. And I use the atmosphere too, because the heat went into the atmosphere. If you take the heat inputs, subtract the heat outputs, that gets your change in temperatures of the ocean. So it's a simple equation, heat input minus heat output equals change in temperature. You can think of it like a box. You heat up that box, and then you have some cooling of that box, and the difference between the two is the change in temperature within the box. They're called heat budget equations. So that's what I used and estimated on the variables. Now the variables, it had to be during an ice age climate, and it was started with a warm ocean. There's no way to be precise. So all I wanted was a ballpark figure of how long was the ice age. Was each ice age 100,000 years, as they claim? They claim each ice age is 100,000 years. Well, but in our calculations, I use minimums and maximums for the variables. See, I wanted to bracket, minimum, maximum. I just wanted a ballpark figure, and that's what I did. First of all, I had to figure out what was the average temperature of the ocean at the start of the ice age, what was the average temperature of the ocean when it peaked. And I used 30 degrees centigrade as the average temperature of the ocean, and I used a figure of 10 degrees centigrade for when it peaked, and it started to melt in this right in here. The average temperature of the ocean right now is 4 degrees centigrade. So when it was still 6 degrees warmer than today, I believe that it peaked. These are estimates. They can be played with. So that represents a 20 degree centigrade drop in the ocean temperature, or a 38 degree Fahrenheit drop. Of course, I give it away right here with the figures I got when I used the budget equations. In these equations, time is one of the variables, and that's why I can figure out the time. So here's my ranges. I got a range for the quickest 297 years and the slowest 1,765 years. The best estimate I figured was 500 years for glacial maximum. Then you had to figure out how fast it melted, you got to figure out an average depth. And so I had to use the moisture source. The main moisture source is the evaporation from the ocean. But there's other moisture sources. Moisture coming from the subtropics and the equator up into the high latitudes. So I used these, and I got a range for here too. I used ranges, maximum, minimums. The best estimate was an average of 2,330 feet for the northern hemisphere. Now, some places would be thin and some places thicker. I think New England was a lot thicker, but up where I live in Montana and Alberta, the ice was a lot thinner. In fact, you know that because the Cypress Hills were sticking up out of the ice, and the Sweetgrass Hills were sticking up out of the ice. So you can calculate the depth, and it was very shallow. In fact, it's so shallow, in fact, it was shallow along the edge of the ice sheet that the uniformitarians have a problem of moving it because it moves by its surface slope. They can't move it from the north to the south because it's so low. Well, in this Ice Age model, it doesn't move. It will move, and it generally moves from north to south, but it generally grows in place. It generally develops right in place. And here's the range for Antarctica, I figured. Then on the melting, solar radiation is the main mechanism for melting, and a lot of it's reflected back to space. And when you heat up the top layer to 32 degrees Fahrenheit, then you start the melting. It'll form rivers on top of the ice, and it'll percolate down until you get to the layer that's below 32, and it'll refreeze down here. But you'll still have a net melting. That's how it melts. I use the energy balance over a snow cover. It's the most scientific way you can to melt snow. And here's the estimates I got. I use ranges for the variables. For the edge of the ice sheet, or the periphery, I got a minimum of 40 years and a maximum of 100 years. The best estimate was 70 years. The time to melt the interior of the ice sheet was about 200 years. So the total time for a post-flood ice age is 700 years. So this gives you an example. When you use different initial conditions, the results are totally different. We don't need 100,000 years. We only need 700 years, which fits in just great within the biblical time scale. Not a problem at all. So the questions, can an ice age occur in the present? No. Then I go to the question, well, they say there were many ice ages. Do we have many ice ages of 500 years or 700 years long? No, actually, there was only one ice age. Oh, excuse me. I believe there were two ice ages. Two ice ages. Now, there was one before the flood. And this was in the area of the Garden of Eden. And it was right after creation, and this is the first ice age. Eve, why are you acting cold towards me? Did I do something wrong? You figure it out, Adam. You know, these problems have started ever since Genesis 3 between man and woman. There's kind of a communication gap. I'm not going to say anything more about that because I think my wife is still here. Anyway, I'm going to go real short on this. You know, the idea of multiple ice ages is mainly an assumption. Because first of all, it took them a lot to really believe in an ice age, because an ice age was so radical, it seemed to be against uniformitarianism. Well, it is. So they said, but the evidence is so strong that we have to believe in an ice age. But to make it sound like uniformitarianism, that they're really easy, they said, well, we had many of them, one after another, so it was just no big deal to have an ice age. Well, in the journal Geology, they found out in Alberta, where they used to say there were 3 or 4 ice ages, they now say there's only one. Glacial reconstructions commonly assume a multiple glaciation hypothesis in all areas that contain a till cover. And notice the title of this, A Single Late Wisconsin Laurentide Glaciation, Edmonton area in southwest Alberta. They believe in only one ice age, and it was in their late Wisconsin time. There was none before that in their time scale. Also, to account for some of a few places, they did see what looked like a till, sand or clay or some organic matter, then another till, and it did appear to be like there were 2 ice ages in some spots. Very small areas. Most areas show evidence of just one till cover, one ice age. That can be explained by one till here. This is a little bit hard to follow. I'll translate it for you. In fact, maybe I'll just summarize it for you. Many multiple successions can probably be explained, and he tells about the sand between two tills. They can be explained by the former presence of subglacial melt streams under the ice, coupled with shifting ice divides and changing ice flow directions. This is all within one ice age, one ice sheet. So you can account for even that data that they think is for evidence for multiple ice ages. You can still account for it within one, and they admit this themselves. These guys are evolutionists, by the way. So in summary, the ice age is really a mystery of the present processes over millions of years model. Noah's flood caused a transition climate for the ice age. The ice age lasted about 700 years. We don't need 100,000 years for an ice age, and we don't need 2.5 million years for their 30 or more ice ages that they claim, since there was only one ice age, and ultimately only the Bible really explains the ice age. And you probably heard that in the 70s, we had a little cooling trend, and they said, oh, the ice age is coming soon. I don't know. Some of you might remember that. I got 3 books on that topic, and there were lots of journal articles. But they're also thinking that the next one's due real soon. In fact, if anyone saw that movie, The Day After Tomorrow, they actually have another theory on the ice age, and that's global warming causes the ice age. It's really funny. I wrote a review in the July impact article for the Institute of Creation Research on that movie, where warming causes an ice age. You know, it's total baloney. There is a little bit. I can't say total. There was a little bit of grain of truth in it, but it was, you know. Anyway, if you want to read more about that, look at the July Acts and Facts from the Institute of Creation Research. Anyway, in the New York Times, this guy said this about a year ago. If the past is any indication, the Earth is at the end of another such warm period, poised to descend into a new ice age. Are you fearful that, I mean, this area was glaciated. Are you fearful that the ice age is going to come here in the next couple of years? I can see some people starting to get nervous and shake in their boots or their tennis shoes. But I can assure you, the Rainbow Promise assures you there'll never be another ice age, because God said there will never be another flood. And the flood caused the ice age. Therefore, there will never be another ice age. So you can cancel all that out of your mind, and I can see the relief on all your faces. Anyway, if you want to know more about this, you can learn about it in an in-depth study I did in 1990 called An Ice Age Caused by the Genesis Flood. Also, for children and laymen, my wife and I combined to write a delightful children's book of life in the Great Ice Age. Suddenly you're teleported to the Ice Age period, and you're just south of it. How are you going to live? Well, the weather's so lousy, you're going to live in a cave. You're going to be automatically caveman and cavewoman. So this is a story of a summer of life towards the end of the Ice Age. What would you do? Would you be out there hunting elk or deer for you that hunt, or fish? Well, you might fish. You'd be hunting woolly mammoths. And there's lots of cave bears in those other caves, and your family's expanding. Well, you got to roust that cave bear out there, so you're going to have an adventure doing that. So forth and so on. And then the second part of the book, I talk more about more details of the Ice Age. This is all in a storybook form. And, of course, if anyone wants to know more about weather, I love storms, and I talk a lot about storming. I talk about the Ice Age in here. I talk a little bit about global warming and lots of other details doing with the weather. And that's the end of my talk, and thank you.